All right, so this is Math 0312, and the first section we are going to cover is 5.1. Now 5.1 is really just an introduction to talking about polynomials and terms and variables and what we do with them, and all of algebra is using variables. And so this is more or less just a little mini lecture on vocabulary. But I'm going to give you an example, 3x squared. Now we can call this a term. We can also call this a monomial because there's just one. And now it's connected by multiplication or exponents, a variable with exponents, and then what's called a coefficient. Notice that there's no addition signs and no subtraction signs. And so this is just one term, and that's why it's called a monomial. Now this is called a coefficient. It is a number, it can be positive or negative, that is in front of the variable. We're going to be talking a lot about coefficients. This is a variable. We like to use letters. Sometimes we'll use Greek letters, but usually not. Just A through Z will do. And then this is, of course, an exponent. And an exponent is usually attached to a variable because if the exponent was attached to the coefficient, we would just do the math and we'd have a new coefficient. So this is a monomial. If we have more than one, let's say 3x squared plus 4x, there's two of them, so like a bicycle, we call it a binomial. Okay? If we have 3, which we'll see a lot of, we'll call this a trinomial. And anything that's more than 1 is called a polynomial. Whoa. That's it. So this is just a really brief introduction to some of the language that we're using. If we have more than 2, let's say I've got 3x plus 4x squared plus 6x to the 5th. Okay? When we're dealing with polynomials, we always like to have the highest variable at the front. So this is called the degree of the term. So the degree of this would be 1 because there's an understood 1 right there. The degree of this would be 2 because there's a 2 there. The degree of this would be 5 because there's a 5 there. And so we like to have it in order. So I would put it in order like this. And then this would be the leading term. Okay? And this would also, not only is this the degree of this monomial, but this is the degree of this polynomial because the highest one wins. And this is also would be called the leading coefficient. Okay? Now, a little bit different. Say we have something that looks like this. Okay? It's a little tricky because there's more than one variable. But to find the degree, we just add up the exponents. So the degree of this one would be 5, and the degree of this one would be 7. And so the degree of the polynomial would be the higher one, which would be 7. Okay? Like I said, this is all just some explanations. Some nerdy math people got together and decided this is how we were going to talk about it. And so, years and years later, this is still how we're talking about it. But one day someone called something a shoe, and we all decided to follow that. So evidently, it works out for us. Let's move on. I want to talk about evaluating functions. This is incredibly important to understand. So p of x equals negative x squared plus 3x minus 2. If I say, what is p of 5, all that they're asking me to do to evaluate this at 5 is to substitute the number in for the variable. That's it. So see how the variable is here and the number is here? I'm just going to fill it in everywhere I see the variable. So p of 5 equals negative 5 squared plus 3 times 5 minus 2. Notice how I put the parentheses there, and that just helps me keep track. So I can say that's negative 25 plus 15 minus 2. Well, negative 25 plus 15 is negative 10 minus 2 equals negative 12. So I know that p of 5 equals negative 12. Let's do it with p of, I don't know, negative 2. Okay, so what is p of negative 2? Well, my original equation was p of x equals negative x squared plus 3x minus 2. So p of negative 2 equals negative 2 squared plus 3 times negative 2 minus 2. All right? And then I do my order of operations, so exponents first. Negative 2 squared is 4 plus negative 6 minus 2. Negative 4 and negative 6, well, that's negative 10 minus 2 equals negative 12. Now, this is kind of a strange situation that I just chose two numbers that happen to be the same thing, but it obviously isn't going to work like that for all of them. And that leads us to the next part of 5.1. The next part of 5.1 is adding and subtracting polynomials. Now, all that you need to know is combine like terms. You're going to hear me say that a lot, so might as well write it down. Combine like terms. And you're going to hear me say distribute the negative. Okay, so here's an example of combining like terms. 4t cubed minus 6t minus 8t squared plus t cubed plus 9t squared plus 2t. Now, all I'm going to do is look at a term and see if there's any other ones with the same variable and exponent. Variable and exponent. So do I have any other t cubes? Yes, I have one right here. So 4 of these plus one more makes 5t cubed. Okay, now let's go to the next one in degree order, which would be t squared. So negative 8t squared plus 9t squared, negative 8 plus 9 is plus 1. But I don't have to write the 1, I can just say plus t squared. Okay? Just like if you have 6 apples and someone takes 5 away, you don't have to put the 1 in front of it, you just say, I have an apple. Well, I have this term. And then negative 6t plus 2t. So negative 6 plus 2 is negative 4t. So I added up my like terms. All right, let's do another example. Negative 3x squared plus 4xy, y because we want to, minus 2x squared minus 5xy plus 7y squared. The important thing to realize here is that, one, we're subtracting two polynomials, right? But we need to distribute this subtraction sign to each one, and then we can just add up like terms. Okay? So do I have anything to distribute from here? No, I don't. So I can just get rid of the parentheses. And the reason why we have to do that is all because of the order of operations. Remember? Please excuse my dear Aunt Sally. So this would be a minus 2x squared, right? But this is a minus, or two subtraction signs, or two negative signs, so it's actually plus 5xy, and then minus 7y squared. And you'll notice how I distributed that to each one. Okay? And then I just add up my like terms. So I have negative 3x squared minus 2x squared. Well, that would be negative 5x squared. And I like to cross them out, but you don't have to. And then I have let's look at the xy's. All right, that's interesting. I've got 4 of them here and 5 of them here, so plus 9xy, and then minus 7y squared. All right, and that is all of section 5.1.